And here we go, number 4. You can see already I have the parent function, the equation factored out there for you. We talked about this in class. If you have a negative inside the square root or inside the parent function, you want to factor it out. Not completely out of the radical, that's illegal. Just split it up from the x with parentheses and change the addition to subtraction. If this was negative x minus 4, this would have been negative times the quantity x plus 4. You make that operation the opposite of what it was. Factoring is like doing the distributive property backwards. So we go through our checklist here. First, we graph the parent function. The parent function for the square root is 0, 0, 1, 2, and 9, 3. 1, 2, 3, 4, 5. There's your parent function in black. Step 1, does it reflect? Step 2, does it dilate? Step 3, does it translate? The answer to all 3 of these would be a resounding yes. It reflects because of the negative in the parent function. When it's in the parent function, it's affecting the inputs. The inputs are known as x. So it reflects the x's over the y-axis. It reflects them horizontally. So that reflection, which I'll do in red, will look like this. Right 1 up 1 is left 1 up 1. Right 4 up 2 is left 4 up 2. Right 9 up 3 is left 9 up 3. The red wing is the reflection. Y equals square root of negative x. That's what the reflection looks like. Next, we have a dilation. We definitely do. We have a dilation out here. Listen to that word, out. Out there, affecting the outputs, affecting the y's. So yes, it's going to vertically dilate by 1/2. You're going to cut all of those y values in half. So this little wing, this red wing, is going to get shorter and flatter by a scale factor of 1/2. This point is 1 unit up, now it's only a half unit up. This point is 2 units up, now it's only 1 unit up. This point is 3 off the x-axis, now it's only 1 and 1/2 off the x-axis. So your graph gets very flat because of the 1/2. Finally, we see the right 4. The minus 4 is bumping it right 4. Try this one in blue. Remember, if we didn't factor out that negative, you may have moved it left by accident. We know that it goes right 4. Every point on the graph, 1, 2, 3, 4 units to the right. This little guy, it was negative 1, comma 1/2. It should move 1, 2, 3, 4 to the right. This point was negative 4, comma 1. It's now going to be at 0, comma 1. And finally, this point was at negative 9, comma 1.5. Move it 1, 2, 3, 4 units. It's kind of getting crowded in there. That's the final answer. You're going to be able to do this on 2 with no calculator. You have to do that process for these different functions. Let's go further with it and do it for all of them, but let's take a look at the table. What I want you to do with the table is I want to use it, and what you want to do is you want to look inside the parent function. Always look inside the parent function. Figure out what the data look like, what value column will be. When you look inside that function, it doesn't matter here or even here. Think, for a square root, what value for x would I put in to produce 0 part? And 4. This 4 is 0. Negative 4 plus 4 for the table. From there, the domain of this, let's see, will it get larger or smaller? If I put in 4, I get 0. Go ahead and work out the math yourself. If I were to put in 5, it would be 5 minus 4, which is 1. Then I would turn it negative. Then I would try to square root it. 5 is bad news here. 5 as an input is no good. 6 is no good. They're producing negative numbers for me to try to square root. By putting a 6 here, that would be negative 6 plus 4. That's negative 2. I can't square root that. So instead of going up from 4, my domain actually minus 4 is negative 1. The opposite of negative 1 is positive 1. I can square root that. The square root of 1 is 1, and 1 times 1/2 is 1/2. Let's put in 0 next. I went 4, 3, 0. I skipped 2 and 1 because putting in 2 would be hard to square root. Putting in 1 would give me 3, which is hard to square root. If I put in rho minus 4 is negative 4. The opposite of negative 4 is 4. The square root of 4 is 2. 2 times 1/2 is 1. Let's check our work. Is 4, 0 on the graph? Indeed. Is 3, 1/2 on the graph? It's right there by my pen. Is 0, 1 on the graph? 0, 1 is on the graph. Our table of values checks out with our graph. Life is good. We move on. Number 6, next video.